Okay, so should in case you get logged out, please, we have a challenge for students who are in boarding house, but they will definitely come home. Okay, so I'm going to record this session. So for those people who are having challenge, um, I will post the video online. Uh, So, so here in this place I just circled, you just get something like who discovered the proton, who discovered the neutron, um, who was the first person to determine the structure of an atom. That's just the three questions that you see under this space. So look for WAEC and NECO. That is WAEC, NECO, JAM. That is what you see in this space I circled. So, but the main chemistry starts when you go down here. So this is kind of very easy. I can talk about this without using slide. So, but what I'm going to do today, I'm just going to try to be guided so that I don't go extensively beyond what we are supposed to cover. So when you are using the syllabus, look at what they are expecting you to do. You see on the left-hand side of the syllabus here. So on the left-hand side of the syllabus, you you have these are the topics. These are, and then on the right-hand side there, these are the core things that you should pay attention to. How do you distinguish between atoms and ions and molecules? Okay, that's basic thing that they are interested in. You see how we deduce the proton number, neutron number, and mass number, and that is very, very easy. Okay, so apply the rules guiding the arrangement of electrons. So this is basically this side here is the very, very important things you need to know whenever you are using the syllabus. So in the syllabus, there are one on the left-hand side, there is one on the right-hand side. The left-hand side are just the concepts that you need to learn. The right-hand side are just the main things that you need to identify in those topics. So having said that, and because it is our first time in this series, so I tried to like, okay, let me go through periodic table at least, so that you get used to something, or you get reminded of. One thing I like about periodic table is that with periodic table, you are guaranteed about, in JAM, maybe 4 questions. That's the new CBT style. At least you are guaranteed about 4 to 5 questions. If it was the pen and paper side, you are guaranteed about 9 questions. Everything you have on this page here comes with about 9 questions when we are doing CBT pen and paper side. Now, but for you doing it in WAEC, for WAEC people, you are guaranteed of a whole question in the theory part, so which makes a lot of sense, and 10 questions in the objective part. So that makes a whole lot of sense. So doing periodic table at this time of the day is not a bad idea. Okay, so I'm going to go ahead to share my the notes. Okay, so welcome to our periodic table class. This is a very, very simple thing. Well, if you are writing WAEC, what you simply need to know is the first 20 elements in the periodic table. So I'm going to share my own experience when I was in high school. So guess what I usually do whenever I get to the exam, or I just draw my periodic table. So this is what I usually do to draw my periodic table. Okay, so I'll just annotate. I'll just come here, see what I do in my paper. I'll just do this. I know you can easily do this. First 20 elements. Remember that your first 20 elements. Okay, so that's, you don't have to annotate on my screen. So, but this is what I usually do. So I'll just come here 1 and 0. So once I have done this is what I usually do. I will just come here 2, 3, 4, 5, 6, 7. So this is 0 or 8. So I'll just, you have to answer all the possible questions in the exam. This is what I usually do. So when I was in secondary school, this is what I did those days. when I was preparing for WAEC. So I'll just uh, rule this, rule this, rule this, and I'll try to do this. Okay, so this is what I usually do. So I'll just come here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So you see, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. When I get to 20, look at what I usually do. I will now come here and I'll write transition method. Okay, I guess I need to stop you guys from annotating on the screen so that you don't uh, make things difficult for people. Let me see. Okay, so can you guys stop annotating on my screen? Okay, that makes it easy. Okay, so stop writing, trying to write on the screen. It's okay. So once you have done this, this is the only thing you need to do. So whatever the question is, so the rest, I told you that the rest is going to be transition method. So whatever, anything, once I count the atomic number of that element and it's beyond 20, just know that your answer is going to be a transition method. So it's scope. So you don't need to be checking, first 20 elements and the rest is transition method. So if they give you an element and then they give you electronic configuration and they're telling you which group does it belong to, you need to think too much. Just count it and see where it belongs to. Very simple. If the atomic number is 1, that means it's in group 1. If it is 11, that means it's in group 1. If it is 15, you can see this is where 15 is. So that means it's in group 5. You don't even need to stress yourself memorizing or cramming anything. This simple secret can help you a lot answer your questions in the exam. But what I'm going to do is just go straight to the notes. And okay, so you don't need to memorize this whole big periodic table and then you'll be fine. Okay, so that is what we are doing. Okay, so this is periodic table showing how the elements are arranged in rows and column. So as you already know, the vertical, so this is group. So vertical is the group, while the horizontal is the period, okay? It's very simple. So I've already dropped this notes, this material on the WhatsApp group. Okay, some people say they are struggling to join. I don't know what else I'm going to do, but I'll record this video, this class. I'm recording it already, so I'll just drop the video. So this is rows and column. Now, you don't need to say how many groups do we have in the periodic table, how many columns do we have in them. This is very simple. You just need to okay, this is group 1, group 2, then this one say the transition method. Remember what I did earlier. Okay, so you just need to remember what I did. Count 1 to 20. Why? If it is why, they only expect you to know 1 to 30. 1 to 20 is where they ask the group, which group did they belong to, which period did they belong to. That is 1 to 20. Then when it gets to transition element, they just ask you which one is a transition element there. And then you automatically know that that is the one that is beyond 20. So that's 20 to 21. So that's kind of easy. Okay, so then I'll just categorize this periodic table into 3 groups: metals, non-metals. Sometimes I put them as semiconductors or transition metals, so which is fine. But I think it's better we do it as we address them as semiconductors. Okay, so here are the metals that you are conversant with. So you don't need to memorize too much. Now, the question is, if it is in the exam, how do I know which one is a metal? Yes. Very, very important. There is group 1, 2, 3. Secrets now. Because it is exam condition, anyone that belongs to group 1, so you can jot it down. Group 1, 2, 3 are metals. This is the only way you can just remember. Group 1, 2, 3 are metals. Group 5, 6, 7, 8. See how I got it down. 5, 6, 7. Okay. Or you can complete it and say, okay, 5, 6, 7, 8. 5, 6, 7 are non-metals. So based on the questions, this way there, 5, 6, 7 are non-metals. Then which one the same? Of course, group 8 is the noble gases. So they don't, most of the time, they will not ask you a question that will involve you classifying halogens as metals. I mean, noble gases as metals or non-metals. Obviously, they are non-metals, but they just classify them as gases. So no big deal. They are still non-metal. Then we also have, okay, so this is where you can classify the metals in the periodic table. And then you have our metalloids. So which is one called, they have like semi-metallic properties, or they sometimes behave as metal, they sometimes behave as non-metals. So those groups that they are majorly like carbon family. Normally, carbon is a non-metal. You know that carbon is a non-metal. Of course, it's paper made from carbon, mainly carbon. So it's a non-metal. You can easily burn. So it's not a metal. But so you can see the metalloids. These ones are just partially conductive. If it is in WAEC now, WAEC is only interested in group 4. That's the carbon family. So they just classify it as group 4. So in JAMB, JAMB is interested in classifying them. The only question that JAMB will ask that has to do with metalloid is simply identifying silicon as metalloid. So that is what JAMB does. If it is in physics, so maybe physics can now extend it and say germanium, arsenic. You know, when you do doping in physics, like doping with metals and non-metals to improve their conductivity. So they use those non-metals, those semiconductors or metalloids for doping. So like silicon and germanium. So that's what they can do. Okay, somebody is asking for the Zoom link. Okay, let me just provide. How do I do that? Okay, let me see. While I continue to do that. Okay, so I don't want to stress us too much, remembering basic things. So these are basic things that you have in chemistry. So of course, we are entered atoms. Yes, whenever you hear of atom, you have a very simple molecule. The smallest substance you can think of in chemistry is atoms. So I don't want to be too descriptive because I'm not doing the calculation. But so but funny enough, as small as atoms are, they still contains protons, neutrons, and electrons. So in chemistry, in exam, how do WAEC or NECO or JAM describe an atom? They'll just tell you, let put X at the top, and then they'll put A here, and they'll put B here. And that's very simple. So very, very simple. That is what they describe as an atom. If they want to describe it as an ion, according to that syllabus, they put A, B, and then they now put maybe plus sign or minus sign. Okay, plus or minus y. Let me just use that one. So whenever you see this kind of thing, they know that that is an ion. The first one is an atom, second one is an ion. So very, very simple as you could imagine it. Let me see if I can get the Zoom link and share it. So some people just need it. So let me just, one moment. Let me just send it to them. Is this guy, okay? One moment, so they can, wait. All right, I think I've sent it. All right, so somebody asked a question. Group 4, what? So usually group 4, I talked about, because you are in group 4, somebody asked a question, what do you classify as group 4? You classify, normally, I don't want to classify them as, normally, carbon is a non-metal. but the persons under carbon, silicon and germanium, based on the fact that we are dealing with first 20 elements, are semiconductors. So generally, when they want to ask you a question about semiconductors, they are focusing their attention on silicon and germanium. They will not ask you which one are metalloids. But if you have a question that involves silicon, then you have to just quickly pick silicon as metalloids. So that is where I classify that. Okay, so carbon is a non-metal, silicon is a metalloid. Yes, that's exactly what I said. Thank you for providing such answer. Okay, so I don't want to argue with simple things. So there are different ways I can answer questions. My focus today is to teach you how to answer questions in the exam. Maybe if you are trying to remember what, there are different ways you can answer questions. So let me pick, let's say for example, they can in jam do not really do all these circle things. So this is, I usually call this one my electron arrangement. It is not electronic configuration. So there are basic things I want you to, I'm going to focus your attention because I want to bring it. Now, this is an atom. In a simple atom, there are shells. So you can see all these black ones, these are shells. And then these ones are electrons. And then you can see this is the first shell, and this is the second shell. This is, I'm going to link it to one very big thing now. Now, here inside this yellow part, this is the nucleus. So it is in this nucleus that you have your protons and your neutrons. So if you're in jam question now, so what I will simply need to do is say, okay, we have X, P, R. So my mass number is equal to proton plus neutron. So here, the number at the top is mass number P, and the number at the bottom is, let me say, is the number at the top is my mass number, the number at the bottom is my proton number, which is the atomic number. But here, you need to find your number of neutron. So you can use this simple formula to find your neutron number. And once you do that, that will take us to the next kind of question that I can or Jap can answer. Oh, if they have the same neutron number, what will you call them? If you have the same proton number, what will you call them? If they have the same electron number, what will you call them? So if they have the same proton number, you will call them isotopes. See? If they have the same proton number, they call it isotopes. If they have the same electron number, we call it isoelectronic. So you can see two atoms can have two different number of electrons. So if they have the same electron number, we call it isoelectrons or isoelectronic. If they have the same neutron number, we call them isotones. Isotones. Okay, so that is, so we have isotopes, then you have isoelectronic, isoelectrons. Okay, so that is one basic thing. Okay, so there's nothing much to discuss. Now, one other thing I need to pinpoint is that in this diagram, there's usually an interaction between the protons and the electrons. Protons are usually positive charge, you already know that, but electrons are usually on the surface. So why I'm interested in this relationship is because when you talk about atomic radius, electropositivity, electronegativity, it is simply because there's an attraction between the protons and the electrons. So that attraction can make the atom to be very small or wrinkled. So you have these protons in the middle here trying to pull these electrons to themselves. What do you think when they pull the electrons to themselves? They're not just pulling only the electrons, they're also pulling the shells inwards. And guess what that happens? It makes the atomic number to reduce. So the more the number of protons in the nucleus, the smaller the atomic number. But we are going to get to that point very soon in this session. Okay, so I don't need to bug you too much. So if it is for, do you have any questions that have are there usually questions that have to do with first shell, second shell, third shell? Yes, I usually have those questions in the exam. So let me say, for example, you have something like this. 1s2, 2s2, 2p6. How many shells are here? How many shells can you see in this electronic configuration? Just 2 shells. So the 1 here is first shell. These 2 are just second shell. So that means this element that has this electronic configuration only has 2 shells. The question they always ask is, how many electrons are in the outermost shell? As you already know, count all the 2's. So you can have this is a 2, and this is also 2. The numbers are at the top, which is what we call the superscript. Add it together, that would give you the total number of electrons there. Let me give you another one. 1s2, 2s1. How many electrons are in the atom? How many electrons are in this atom? So just count it. 1, 2. So if you add the 2 that I've circled at the top together, you see here that it is total of 3. So that 3 represents the atomic number. Very simple. If you want to answer questions in JAM, the 3 represents the atomic number. So the question is, how many electrons are in the outermost shell? How many electrons are in the outermost shell? So if you find out that we have 2 simple shells here. Let me just show you. 2 shells here. The first shell is 1. Can you see here? This one here. This big one I circled. And the second shell is this one. So on top, so in the second shell, we only have just 1 electron here. So this is the electron. So that means it just has only 1 electron. So how do I know how many shells are in a given atom? Well, you can just distribute using this first shell, using this formula 2n squared. So if you are dealing with n tells you the principal quantum number. That's what n represents. But it's just telling us the energy level. So if n is 1, that means you have only first shell. If n is equal to 2, that means you have second shell. So that can tell you how many electrons are there, and you can also use that to find out from the atomic number how many shells are in that element. But nobody usually asks how many shells does the element have. Have I ever seen that question before? Yeah, maybe once. I think maybe they just ask, in which shell do we have the outermost electron? Yeah, that was I think they gave something like this. 1s2, 2s2, 2p6, 3s1. In which shell do we have the outermost electron? Of course, in the third shell. Now, the question, okay, I remember the question now. You say, which of the shells do we have the outermost electron? Guess guess the options that they had. A is equal to K, B is equal to L, C is equal to M, D is equal to N. Think about it. They gave you this. They gave you this electronic configuration, and they're asking you which shell is the outermost shell in. So very simple. You have to be very, very smart. Just as you want to. I'm just teaching you all the secrets in your exam questions. Everything I'm doing here, I'm referencing it to questions that you will see in the exam. Okay. So how do I know the first shell? Which is the first shell usually K, second shell is L, M, N. So following that order. So if I'm in the first shell, I'm only interested in let me clean this guy. I'm only interested in just this guy, 1s. Anything that starts with 1s, that's first shell. That means that's K. Anything that has to do with 2s, 2p, they are all second shell. So this one and this one is L. So 3s1, that means this one is M. You see, very simple. So if you have 1s2, 2s2, 2p6, 3s2, 3p6, that means everyone that has to do with 3 is on the third shell. You see, very, very simple. Yeah, it's very, very important that you just remember this. Okay, it's not as difficult as I don't want you to imagine that the chemistry is so difficult. But if you have any question, just simply drop it on the chat or on the WhatsApp group. I'll try my best to see it. Okay, so these are how are electrons arranged in the periodic table? So that's for you. I don't need to bug you. We have already seen the periodic table, so nobody will ask a question on this slide. which atom is shown by the electronic configuration. This is just for you to play around, maybe when you download the paper. So how will you know? It's very simple. You see, proton number is what we are using to represent it. But you can see here that all these illustration I showed you, they are all atoms. They are all atoms. That means there is no charge. We can see there is no charge here. So whenever they are all atoms, that means they have equal number of protons and equal number of electrons. So the number of protons and number of electrons are just the same. So did they follow alphabetical order as the shell increases? Yeah. K, L, M, N, O. Yeah, that is the way. So starting from K, L, M. So and then I've answered that question. Thank you very much, Nifesimi. Good job. Okay, so all what it's an atom, so because it's not carrying any charge. Remember what I told you, how to differentiate between atom and air. So for those who have just joined, let me just re-illustrate it. So you just have the sign like this: X, M, N. That is an atom. You now have X, M, let me just use, let me not frustrate people. N, M, maybe +2. So that becomes an ion. So based on what we have here, once it is an atom, the number of protons and number of electrons are equal. Just count the electrons. Simple. They have 2, 4, 6, 7, 8, 9. Okay, very simple. And 9 is a number of electrons, and which is F. Thank you very much for answering that question if you tried attempting it by yourself. Okay, so I think I've talked about isotopes a little bit. So, and then it is objective, so I don't need to force too many information in your head. It's an objective, so you need to know which one is isotopes. How do I know that they're isotopes? They have the same atomic number, which is proton number. Remember, isotopes, not isotones. So we have 6 and 6, 13 and 12. So the mass number is different. So the moment the mass number is different, automatically the number of neutrons will be different. So that tells you that you have two reasons. If it is a why we ask you why, what's your reason? Of course, the mass number is different and the number of neutrons are different. That's the two reasons why we describe them as isotopes. So very, very simple. Don't just give only one reason for why, two reasons for why. Okay. So the common ones that they will always ask you is these are chlorine. So chlorine and chlorine. So you have chlorine 35 and chlorine 37. And then they will ask you 17, 17. They will cannot ask you, what is the proton number? I've already answered that question at the beginning of the class. Proton number is usually at the bottom. See, this is proton number. Thank you. What is the mass number? 35. Okay, for that one. For the other one, 37. Now they ask you, what is the number of neutrons? It's very. So will all these questions come out in UTME? Come on, we are practicing. I'm not the one that said UTME. I'm just showing you scope on how, what you definitely is, what you most likely see, and how you solve your problem. Okay, so you just differentiate. So subtract the proton number from the neutron number, and you will definitely be fine for the number of neutrons. So that is why they are isotopes, because 35 minus 17, here will give you 18 neutrons, and here will give you 20 neutrons. You can see there are two things that are different: neutron number and mass number. That's why they are called isotopes. Okay, no need to be wasting time on that. Let's move on. There are so many things that we can talk about. Modern electronic configurations, yes. What they will always ask you here is using the electronic configuration. I don't need to be teaching you how to write electronic configuration. I definitely believe that you will be able to write electronic configuration. But should in case you do not remember how to write electronic configuration, I think it's in the next few slides. Usually starts from here, and then you can be able to do. For WAEC people, we only care about S. If you are doing WAEC, WAEC cares only about S and P orbital. The shape of the S orbital is already on the screen. The shape of the P orbital, that is the only thing that WAEC cares about. If you're interested in JAM, yeah, JAM can ask you questions about S orbital, P orbital, and D orbital. Nobody asks you question about F orbital. So what about relative abundance? Will it be covered? I'm so sorry for disturbing, but I just joined, so I don't think uh, I'll, I didn't get from the beginning. So I would like to have your WhatsApp number. If you check the flyer, somebody said if you check the flyer, you see the WhatsApp link there. You can join the WhatsApp link. I recorded everything in this class, or I'm recording it. So I will still post the video if your network suddenly messes up or you're not getting the right. Okay. So WAEC asked you about the shape. S orbital is spherical, and P orbital is dumbbell. See, you can see here in my test in my screen, I deliberately um, drew only one shape of the P orbital because I can draw P orbital in different ways. So don't suffer yourself drawing everything. So some people I usually tell say I have X, Y axis, and the Z axis. Okay, so very simple. I can just draw it like this, and that is your P orbital. You don't need to be showing us that you are an excellent student by drawing all the three of them and making your work look so interesting by looking so hazard, I will call it, or haggard. Please, just draw only one. WAEC knows that just one enough is enough for you to represent as your P orbital, or don't need to draw the three of them. If your teacher in school has already told you that, oh, you need to draw the three of them, no, it's not necessary for WAEC. So WAEC done only S and P orbital. JAM will only ask you S, P, D. Okay, so I'm going to bring questions and see what we can get from F is just for you to like freestyle, for you to have a proper knowledge, in case maybe you get to do A levels and not the rest of them. That is for diffused. And this is the number of electrons that can hold. Okay, so no big deal about this slide after you have taken numbers. Okay, another thing that I talked about, yeah, JAM question. JAM can always ask you about the quantum numbers, the principal quantum numbers. So JAM will use the letters N for principal, L for the subsidiary or called azimuthal. That determines the shape of the orbital. It's in JAM question. So M is the magnetic quantum number. So and S is the spin quantum number. So every electron has two spin. So positive spin and negative spin. So this is the positive spin and this is the opposite negative spin. Very simple. Okay. No big deal about this whole thing. It's just for you to know which one represents the energy level, which is the principal quantum number. Which one tells us information about the shape of the orbital is the azimuthal. That is what they ask you. Okay. How many spins does an electron have? Just two possible spins, up and down. Sometimes you have it like this, or sometimes you have it like this. So it's still the same thing. If it's either a half spin or a full spin, both of them can represent. It depends on how the typist, which shape the typist sees when typing the question. Okay, so but they just have to be consistent after they vetted it. Okay, so no big deal. Is there anything I need to know about quantum numbers other than this, brothers and sisters? For you to pass WAEC or JAM, this is just the only thing you need to know. Okay, no big deal. If you are still remembering, if you've forgotten how to write your electronic configuration, this is just a simple slide that tells you all these things are already in the notes. You can go from 1s to 2s, just follow the arrows, then to 2p, 3s. My major interest is how to know how to answer questions that come after you have written the electronic configuration. JAMB will not tell you to write electronic configuration. You already know that. But they will ask, okay, how many electrons are there? How many electrons are unpaired? Which period does it belong to? Which group does it belong to? How do we identify those things? Are the things that we need to do? Okay, let's try. I'm not writing electronic configuration. It's just for you to play around. But let's just see. I'm going to pick one. Let me pick nitrogen. Nitrogen is number 7. So let's just see what are the possible informations that we can get from the periodic table. So let's say you write 1s2, 2s2, 2p3. So what are the things that I can get from this electronic configuration? Before I go to those things, first, if you are writing WAEC this year, please, in the name of God, if your teacher have not told you or the teacher have told you, I'm reminding you that please don't put comma because you have to differentiate. We don't need it. Automatically, if I'm when I used to mark work maybe like 2 years ago, the moment you put a comma, automatically that have spoiled the whole chemistry. Even if you got everything correct, we'll just give it to you 0. I won't even think twice. I won't say, hey, yeah, nothing like, hey, yeah. The moment you put a comma, you have spoiled it. That is not what we can ask you to do. Just remove all the commas. Don't even try to differentiate and put dots in between them to show that, we can see your writing. Some students have written this like this. Okay, I've seen students write like this before. 1S, 2, 2S, 2, 2P3. I can still give it to you for writing like this. But the moment you put a comma in between them, no mercy. Please, that is WAEC rule. WAEC does not appreciate that. Back to the question, what information can we get from this periodic table? This should be the biggest thing I'm going to spend my time doing today. Come on, please stop annotating on the screen, it doesn't help you. Unless you want me to stop you guys from participating. Okay, that's very easy. All right, so what are the informations you can get? First, I'm going to show you this one represents these numbers represents first the shell. One there represents the first shell, 2 there represents the second shell. Another information that we are interested in, you can see that the highest number of shells that this element has is 2. Though automatically, that biggest number there tells you about the period. Very simple. So that means is that the period 2 element. Very simple. That is a period 2 element. So now the question is now, how do I know the one that is group? You can see I have 2 circles that are representing the period. So this one and this one. That is the 2 period, the 2 largest numbers there that are in the period. How many electrons are there altogether? So these electrons are what is on top of them. 2 and 3 make up 5. So that 5 is the group number. Very simple. Very, very simple. You don't need to kill yourself memorizing nitrogen is in group 5, nitrogen is in group. It doesn't work that way. Just from this electronic configuration, this is the biggest thing. I'm going to show you a lot of things that I can get from this periodic table. Another thing that I can ask you, or JAM can ask you, is that how many unpaired electrons? I'm sure you must have seen that question. How many unpaired electrons are there? Now, this is where it becomes very, very tricky. Now, in WAEC, they can now begin to tell you about the ground state or the excited state. Just relax, don't be scared. They don't terrorize students that much for nitrogen. But if you are talking about ground state, just the normal electronic configuration without applying any energy, that is ground state. I'm still going to mention about excited state. Okay, so look at what I'm going to do here. Now, how many unpaired electrons? Just go straight to that electronic configuration. Let me even clean all this I've done. I'm done with all these ones here. So go straight to that electronic configuration. What is the last electronic configuration written there? Which one is the last one here? The last one here is this guy here. It's very simple. There are 2 ways you are going to do it. Is either you deal with that one alone, or you deal with the 2 of them alone together. So I'm going to do A. A is alone, is the whole shells together, and B is that specific orbital. So if you are very good, what you simply need to do, I'm going to deal with the whole outermost shell. So that is the outermost shell. Just draw a circle like this. There are 5 electrons. Distributed 1, 2, 3, 4, 5. How many unpaired electrons do we have now? 3. Straightforward. No cramming. The way it is the way you enjoy it. It's so easy. Now, if you do not, I hope you understood. Let me repeat what I did. I'm going to clean this thing so that I will do it again so you grab. Now, as you can see here that This is the outermost shell, this guy here. That's the one that has 2. And the total number of electrons is 5. So just draw a circle. Remember, the innermost shell has only 2 electrons, so we don't care about this. So, but the outermost shell has 5 electrons. So just draw a big circle. And make sure usually I double it. Just draw 1, 2, 3, 4. Then you now begin to double 5. Now, I'm out of electrons. Now I've only doubled 1, but I have 3 unpaired. So I have 3 unpaired electrons. So that's a very easy way of doing it. If you know this, if you don't have to remember this one, let's say, for example, you get a very complicated atom. All you need to do is very simple. Just pick the last shell, the last orbital there, and this is the last orbital. So we have what we call energy block diagrams. If it is S, P, D, F, so S block, P block, D very long block. Okay, we don't want to care about F because nobody will ask a question about F. So S is just 1. So P, you divide it into 3. D, you divide it into 5. See, this is for people that are chemistry experts that have understood this earlier one. Then, of course, I don't care about F because nobody will ask a question about F. So let's not worry about F. So we don't get scared because of Mr. Nkwocha. Okay, now, according to Hund's rule or Alva principle, which you are going to see in the next slide, you remember that Hund's rule, when you are filling electrons into orbitals, they should be singly filled before you pair them. Remember, as Hund's rule, H-U-N-D, Hund. When filling electrons into orbital, so we are filling electrons into this 2p orbital, they should be singly filled before pairing. Now, this electron is on p, so I don't care about this guy here. So I should go straight to the p orbital. So now I have 3 electrons. So I fill this on 1, 2, 3, and my electrons are complete. So in that way, very simple. It is still 3 unpaired electrons. I cannot pair them because I don't have any more electron. What if I have P5? Okay, P5. How many electrons are unpaired in P5? Just draw the normal P again. 3 boxes. 1, 2, 3, 4, 5. I have only 1 unpaired. Can you see? So at that point, we are just having 1 unpaired. So if it is P6, that means fully filled. If it is P6, what about P4? On your own, do P4. How many unpaired electrons do you have on P4? Yeah, put it on the chart. Let me see if you are following. Excellent. Somebody have already answered the questions. Very good. That's fine. Thank you. Sir, good afternoon, sir. We will also be discussing organic chemistry and we will be having this class during next week. Yes, this class every Friday, every Saturday until you write your JAMB. That's the best I can offer, and it's free. I won't ask you to charge. Most of us have school and won't be able to join. If yes, will recordings be sent to the WhatsApp group? Okay, I can easily send the recordings on the WhatsApp. Yeah. If the WhatsApp is better, let me know even so far. As long as you have the data, just go ahead and download it. I will send the recordings to our WhatsApp group. So for those who missed it, no big deal, right? That's fine. Okay. So thank you guys for answering that question. It is 2. Thank you. That means you are following. Now the next thing, so let's say we have been able to identify unpaired electrons. That is perfect. I don't need to bug you too much again. What other informations can we get from having a hair? Very, very simple. Okay, I remember the question. Another question is it a metal or a non-metal? They gave you electronic configuration. Which of the following is a metal? So you like, this man did not teach us this thing. Oh, my chemistry teacher is wicked. He didn't teach us it. No, your chemistry teacher is not wicked. He just forgot. Okay, how do we know if it is a metal or non-metal? Now we just saw that P should take about 6 electrons. S will take about 2. D will take about 10. Point blank. Let me give you a secret. The moment, okay, let me see what I can do. Let me look at it. Okay, easy peasy. My children will say easy peasy. So let me just see what I'm gonna do. So one of the easiest way to know is soft touch. If it ends with S, let's say for example, 1s2, 2p. Oh, I'm on. I don't do it. 1s2, 2s2, 2p1, 1s2, 2s1. So the moment it ends with S, automatically is a metal. Whether it's S1 or S2 is a metal. And then P1, S1, so is a metal. That's very easy. Now, when it gets to P3, that means we have the tendency, we are going from P3 to P6. So that means this element has got to halfway. Once it gets halfway, automatically is a non-metal. Half of 6 is 3. So once it gets to 3, it's a non-metal. Yes. How do I know that it's a non-metal? Well. Remember what I told you at the beginning of this class, that you should always draw your periodic table on one corner of your answer script to be on the safe side. So remember what I did. No matter how big your, no matter how small your paper is, you can always draw something like this. Let me just see. 1, 2, 3, 4, 5, 6. Let me just divide this one. 7. Then you can just, this is the easiest way to do this. But the other way is, now, if it is for non-metals wants to share electrons. Non-metals, I just mentioned share. Yes, because I'm going to covalent bonding now, electrovalent bonding. If it is sharing of electron, non-metals will always want to share electron. The worst thing that can happen to a non-metal is to share. It's either they collect electron or they share. Non-metals will never give you an electron. Why is it difficult for them to give you an electron? Because they are halfway filled. That's the simplest answer you can give to you. Halfway filled. If it is P1, think about it. P1 and P6. Which one is? How do you think P1 can go to P6? Can it ever gain electron? It is going to gain 5 electrons. So that means it's going to gain 1, 2, 3, 4, 5 before it gets to P6. If an element is P1, that P1 is going to be a metal because it is easy for this element to lose this P electron and becomes a full S and becomes an S than for it to gain. Yeah. So a metal will rather lose an electron. So because let me place for example now. Let me clean this thing and show you an illustration. Let me give you 1s2, 2s2, 2p1. Mr. Nkwocha have already told us that the moment it is S1 or S2 is a metal. Now this guy here is P1. It needs to get to P3 before it start before it will behave like a non-metal. P3. I'm very, very serious about this. You won't get it outside here. Once it gets to P3, it's a non-metal. That is the reason why I always classify carbon as a non-metal. Because look at carbon now. Carbon is a very weird guy. Let me keep because of jump. I'm going to answer. Carbon is number 6. 1s2, 2s2, 2p2. Come on, carbon. So look at carbon. This is the p orbital of carbon. Just has 1 electron here. So why will carbon be a non-metal? You see, that contradicts what Mr. Nkwocha is just saying. This is what we call the ground state electronic configuration for carbon. I mentioned it before, excited state and ground state. You will see it very soon. Maybe when you're practicing online question, you will definitely see that kind of well. So this is the ground state electronic configuration carbon. Before carbon can react to form organic chemistry, carbon dioxide, any compound of carbon, it must be in this excited state. And in that excited state, it will promote this, see this 2s2 here now. It will promote this one here, one of them to come here. So it now becomes 1s2, 2s1, 2p3. That is exactly what happens. That is in the excited state. When you are excited, like me, I'm smiling now. Why? Because I'm happy that you're following my chemistry, you understand my chemistry, so I'm happy. That means that it's a form of, I've gained some excitement, some energy. So your understanding makes me excited. In chemistry, once you bring energy to any atom, it gets excited, it becomes very happy because they want to move, they want to jump around. That is the excitement. So once you give carbon any small energy like this, the excitement pushes one of these 2s electron to this one so that it now become this P3. 1, 2, 3. In that case, carbon can now share its bond to form a tetravalent. You know, the oxidation state of carbon is for the valency of carbon, sometimes you have carbon 4 or sometimes you have carbon 2. And you know, in your chemistry, the teacher will say carbon monoxide or carbon 2 oxide is unstable, Once you expose it to oxygen, once you expose it to air, it will change the carbon dioxide. Why is it unstable? Because it's losing 2 electrons. Because it has to lose 2 of those electrons so that it will become 1s2, 2s2. That doesn't make any sense. But it becomes stable. It's something that's so easy to do. Once you expose it to oxygen, it will just get promoted, exciting one of those electrons from these 2s to 2p. In that case, it becomes stable carbon dioxide. And that's why carbon dioxide is very stable in our environment today, causing greenhouse problems. And that is very, very key. So back to it. So back to that question, how do I know if it's a metal or a non-metal? Once it has S and P1, that means it's going to exhibit metal property. So now you're not going to be seeing some variations. Something like boron, boron. Boron is number 5 in the periodic table. Hydrogen, helium, lithium, beryllium, boron. So that means 1s2, 2s2, 2p1. You see, boron is going to be a metal. Yeah, very simple. Just like aluminum, 1s2, 2s2, 2p6, 3s2, 3p1, P1. So very, very simple. So when they get to P2, that's when you begin to talk about metalloids. They are beginning to move around. Good afternoon, sir. I'm still in senior secondary school. I have not started with this topic, so I don't understand anything. I'm so sorry. That's why this class is for UTME student. I can't be teach. Okay, so we are preparing for exam. So that is exactly what is happening there. I hope you guys got this in very clearly. There is no secret about this thing. Chemistry is not difficult. Okay, so I'm just going to move on. Okay, I've shown you this D block. So once you download the notes, you will see all this D block and all this explanation I've been mentioning since. Okay, so alpha principle. Yeah, I think I've already mentioned. I've talked about Hunt's rule. I didn't mention alpha principle. So alpha principle just shows you how you feel electrons in order of increasing energy. If we're going from 1s to 2s to 2p. So Pauli's exclusion principle, that's another thing that students joke, forget how it is applied. And JAMB will always trick you. So JAMB will come here and draw this electronic conversion. They'll not do 1, 2, 3. They'll not do another one. 1, 2, 3. They'll not do another one. 1, 2, 3. Okay. which of these things I have drawn here is correct? Which rules are being obeyed and which rules are being disobeyed? Okay, so very simple. You see, so let's go. I can see okay. So now in this this is WAEC now. I think 2008 WAEC or 2009 WAEC has this kind of question. Either WAEC or GCA. Now this first one, this is A. This A, number 1, disobeys Horn's rule, because it's supposed to be singly filled before pairing takes place. You see? So that one disobeys Horn's rule. And again, another rule that it has disobeyed, disobeyed Avval's principle. So this one, this A disobeyed Horn's rule, is also disobeyed Avval principle. How did he disobey Avval principle? Because we are saying here that electrons will enter into orbitals in order of increasing energy. And this is a p orbital. All the orbitals have the same energy level. So take note, this is px, this is py, and this is PZ. So maybe in case you see PS, PY, and PZ, all of them have the same energy. So we don't expect PX to have 2 electrons when PZ does not have any electron at all. So that means automatically it has disobeyed Aufbau principle. Then let's go to B. This is B. The B obeyed Pauli's exclusion principle because electrons, all of them have a single spin. It has obeyed Aufbau principle, and it has also obeyed Horn's rule. Now let's go to the third one. The third one, which is our C, this C has disobeyed Aufbau principle because the last block there did not have any electron. Number 2, it has also disobeyed Pauli's exclusion principle because this is PX. This PX is an orbital. They are not supposed to have the same number of electron spin, but they're having the same kind of spin. So automatically, the spin are facing the same way, there's going to be an electron-electron repulsion. So that means that Pauli's exclusion principle has been disobeyed, and Hund's rule has also been disobeyed. Okay, so that's, you can see how we apply those kind of questions. Very, very important that you don't mess around with these kind of simple tricks. Okay, so this is where those questions are usually bringing. You have exceptions to electronic configurations. You don't need to force away learning this one because it's just easy. So let's switch gears. Usually I do this class for 1 hour. So, and it is 7:05. Your data is about to finish. My data will never finish anyway. But what do you think we should do? Can I finish this periodic properties, or I should move on? So I need you guys to vote. I can do it in 15 minutes. If you think we should continue, okay. Somebody said I don't understand electron affinity. Okay, excellent. I can do that with you. Should I do all the atomic radius, electron affinity, electron negativity? Is that what you need? So that I know that I've taken care of periodic table. I just need you to say, okay, excellent. So I can do that in 15 minutes so that you can go home and read, and then we are not going to come back to periodic table. We can only answer questions on the WhatsApp group. Anywhere you see questions at all, just send it to me on that WhatsApp group, and then we'll be done. Okay. Okay. Now this is one of those, the first thing you get into SS2 chemistry is to cram periodic law. I don't know why I've asked students to state periodic law in the exam. Why would I even be telling them to state it in the exam? Just because of WAEC. WAEC will only tell you to state periodic law. But the main chemistry is what we are going to talk about. So it says that the properties. So we have properties, physical properties, the chemical properties. Look at this chemistry over there. It says the periodic. Since you guys are all science students, periodic properties. You know, you've heard of simple pendulum, right? You swing to the left, you do your pendulum bob up, right, and you go up and come back. We say 1, you do again 2. Come on, periodic. That means it goes up and comes down. It increases and then decreases. That's what it means. That periodic. It will just appear and it will increase and then decrease. It will increase and then decrease. So those properties of the element increase and decrease based on the atomic number. Why would the person that proposed this even be talking about based on their periodic somebody say the volume. The volume is clear. Check. Okay, thank you. I was scared. Okay, so let's see. How do we do this? Why would you even say based on the atomic number? Why, for God's sake? Well, if you have never known before, the periodic table of the element is the arrangement of the elements in order of their increasing atomic number. Yay! So you can see here that in the periodic table, we are going from 1, 2, 3, 4, 5. They are all arranged in order of their increasing atomic number. So as the atomic number increases, see the scope. You are WAEC. Even if you don't know anything, even if you cannot remember anything, remember what I'm going to tell you. Just remember this: as the atomic number increases, these properties will also change. So the properties can increase or can decrease. If you model it up in the exam, you must not just say what is the reason for increase in atomic excitation energy. Just say atomic number increase. Anything you cannot remember, just write atomic number increase. In fact, that is funny enough, that is the answer. That answer applies to a lot of things. So, what is the reason? Increase the atomic number. What is the reason? Increase the atomic number. If you cannot remember anything, just remember that one. That one online chemistry teacher told you that, in fact, one answer is increase the atomic number. If you cannot remember anything, why atomic number? Why electronegativity is behaving this way? Why ionization energy is behaving this way? Why electronegativity or electron affinity is behaving this way? Okay, now, ladies and gentlemen, remember one thing I told you before at the beginning of this class. What I did was I drew an atom, then inside the atom, I now drew protons and neutrons. And I drew an electron here. I told you that these electrons are being attracted by the protons. There's an interaction. That is the secret to understanding this periodicity. So check out what happens. The moment you see what I'm going to do, this is 1 on top here, 2, helium, 3, 4, 5, 6, 7, 8, 9, 10. Ladies and gentlemen, once I go across the period like this, see, I'm going across the period. I'm going from left to right. I'm going across the period. What am I doing? I am increasing the atomic number one after the other. So across the period, I am increasing the atomic number. You see? And this number here is shell number 1, shell number 2, shell number 3, shell number 4, shell number 5, shell number 6, shell number 7. Remember what I told you about the shells? I told you that the shells represent the period. So as I go down the group, I'm going from shell number 1, shell number 2, shell number 3, shell number 4. So easy. So if as I am going down the group, I am increasing the atomic size. Why? Because I'm going from one shell to the other. So I'm going from one shell. See what happened? I've increased the shell number. I've gone down the group. The number of shell increases. You see? That means the size of the atom increases. Once I go down the group like this, the number of shell increases, the size of the atom increases. Isn't that what atomic radius is telling you about? Radius in math, from the center to the atomos, to the circle, or to the circumference. So down the group, the number of shell increases. Can you see? But across the period, the atomic number, can you see the two differences? So atomic number is what is increasing across the period, across the group, that's across the period, from left to right. But once you are going down like this, the number of shell is automatically increasing. That is, so if you have any question that has to do with atomic size, atomic radius, just know that down the group, atomic size is increasing. Why is it increasing? Because the number of shell is increasing. Across the period, the atomic size is decreasing. Why is it decreasing? How can it decrease when the atomic number is increasing? Oh, you already answered the question already. Across the period, from left to right, the atomic number is increasing. That automatically decreases the atomic size. Why? How? Come on. Let me show you one simple joke. When I used to teach high school students, okay, I have like in a class, you have mostly in science class, you have a lot of boys there. I don't know why, but in those days, we usually have more boys. So when boys want to have female friends, they'll just go to the commercial and say, But think about it, once a girl enters like this, you're a science student, first, oh boy, every boy is interested. They just want to know who the girl is. Because there are so much protons. Everybody is pulling towards the electrons. So what happens when you pull towards somebody? They are reducing the distance. They are reducing the distance between the distance will reduce, because if it's only boys, who cares? Everybody just sits on their own chair. But once a girl comes in, come on, all the boys just want to be interested. They want to have a conversation. They just pull towards. So on pulling towards, they decrease the class size. What happened to the class? The class is no longer dispersed. Everybody just clustered in one area and they are gisting and they are laughing and they are happy. That is the very plain truth. So what happens is that once the number of protons is increasing, the attraction towards the electron that is in the outermost shell is also increasing. And that will reduce the distance. And so that is why we say across the period, atomic number increases, internuclear distance decreases. That's the nuclear distance. I've used one big chemistry word now. Nuclear distance. Instead of calling it atomic radius or whatever, I can call it internuclear distance. So across the period, atomic number increases, and guess what happens there? Nuclear distance decreases. Now, guess what happens? Boom. That, my friend, that is talking about, okay, let me talk about electronegativity. No, let's talk about, before we go to electronegativity, let's talk about ionization energy, because all of them are linked together. I'm going to link everything. So look at what happens there. Once you have increased the atomic number, so that means there's a closeness between the protons and the electrons. So they are attracted to each other. So there's a grip between the protons and the electrons. So that grip makes it very difficult to remove an electron. Yes. So that energy that you're going to use to remove that single electron is all called ionization energy. Will it increase across the period? Yes, because you are increasing the number of protons. So the more there are protons, the more that grip. That's what we call nuclear attraction. So the more the protons, the more the nuclear attraction, and the more difficult it is for electron to be knocked out. So think about it. Let me give you an illustration. Let me clean this thing. Very simple illustration. I don't want to waste your time because I told you that you have to go and do other things. So this is our nucleus. And this nucleus, we have only one proton. Now check out this. We have only one electron here. Now I'm going to draw another one on my left hand at the bottom. You have a new proton. This is our proton. Nucleus, proton, proton. So I have like 4 protons there. Now I have the same electron. So now, what do you think? Where will you have more attraction? Is it the one that has more protons or the one that has less proton? Obviously, the one that has more proton. So that's why we say across the period, once the atomic size is reducing, yes, I have the full video, I'll post it on WhatsApp. Once the number of protons is increasing, the atomic size will decrease. That attraction between the protons and electrons will increase, and that attraction is called nuclear attraction. Once there's an increase in nuclear attraction, automatically it will be difficult for us to knock out an electron. That means we need so much energy, and that's ionization energy. And then once that is done, think about it. Another phenomenon that happens here is that let's go to another phenomenon is electronegativity, but I'm going to talk about that by telling you here that let's have 7 electrons, and I have I have a lot of protons. I have 1, 2, 3, 4, 5. Okay, let's have 5 protons. So here I have only 1 proton. If there's an electron here, and these two shells, shell A or atom A and atom B, both of them wants to attain octets. That means they need 8 electrons. And an electron is coming. Who do you think will attract the electron? Who has the ability to convince the electron that if you join me, you're joining a big club like Manchester City or Real Madrid? Yeah, for the boys, I understand. So, of course, it is atom B. It has enough electrons already. So it will be easy for atom B to convince this single electron that is coming in to join his gang than atom A. Atom A is somebody like sodium, group 1 elements, group 2 elements, group 3 elements. What do they care? They are going to convince as much as, for somebody in group 1, they're going to convince 7 more electrons to join them before they can join, they can get to octet. So they better go to relegation, like Derby County. They should better go to relegation by just lose 1 match, lose 1 electron or lose 2 electrons and go back to relegation so that you can be stable. But this guy, atom B, has 5 electrons already. So it will be easy for the guy that has 5 electrons, 6 electrons, 7 electrons to attract 1 more electron. That is why we say that's why electronegativity increases across the period. Why? Because there's an increase in the number of electrons. I don't have to use the number of electrons. I told you 1 word, increase in atomic number. once there's an increase in atomic number, automatically it is easy for those atoms to attract an electron to themselves. And that makes a lot of sense. The last guy here, for something like group 1 elements and group 2 elements, they just have one more electron. They'll just have one lone electron in the atom shell. So it's very difficult for them to convince electron to join them. So they prefer to lose. So that means they become highly electropositive. That means the energy that they require to lose an electron, it's easy for them to lose an electron. I'm having my class. Okay. Now, the next thing you talk about is electron affinity. Now, this is the problem again. Electron affinity is that energy change that happens when this B accepts this electron. Guess what is going to happen? Jealousy will come inside. I don't know why I'm saying jealousy. But guess what? Once they have like 5 electrons, 6 electrons, 7 electrons in the atom shell, and they're bringing in an electron and another extra electron. Oh, do you know what will happen here? There's going to be electron repulsion. So electrons in the atom shell will begin to repel that lone electron. And guess what will happen? To now take more energy again to overcome that energy barrier so that the atom can join them. So we say electron affinity is the energy change that occurs when an atom acquires an electron and becomes a negatively charged ion. So basically, it's going to definitely increase across the period because they have more protons and there's also more electron repulsion. Okay, so that is how you explain those phenomena. So in the exam, where I could just ask you, how does it increase across the period? Does it increase or does it decrease? So the slide has all this explanation. That's what we call periodicity. So across the period, it will increase. Ionization energy increase across the period. You can see it on the screen. Electronegativity and electron affinity, all of them increase across the period. Down the group, they decrease. Okay, so that is basically how we answer those questions. And what are the reasons? You can see, I've already shown you it here. The reasons are very, very obvious. And the reasons are on this slide. I don't want you to cram. Remember, it is usually increasing because of an increase in number of protons. And then, or down the group is increasing because of an increase in what? The number of shells. Okay, so that is basically how this thing happens. So ladies and gentlemen, I told you 15 minutes. So this is a usual 1 hour class. So wherever we have an extension, I will just like just extend it for like 15 minutes. I wouldn't want to bug you guys too much because I use 5 minutes for introduction and like telling you about the WASSCE and JAMB syllabus. But basically, I will let you know that for this lesson, it's 1 hour class, and I know I would try my best to post it on the WhatsApp group. So if you are not on the WhatsApp group, look at the link at the bottom. BITSS. Let me so I will try and see if I can push the link on the group. Let me just see if I can. Let me put the link on the WhatsApp so that okay, I'll put the link on the chat. So if you have not joined this group, you can just join. And the notes is also posted on the WhatsApp group. Let me see if I can post the notes here so you don't have to do a double download. I know a lot of us are yeah, if you have not downloaded it. So I just tried to upload the notes here also. Okay, so that is how the cookie crumbles. And next week Saturday, please post the topic you want us. You have electrolysis, periodic organic chemistry. If you have any topic of interest, just post it on the WhatsApp group. The more topic that I see that students are interested in, that will be the topic I'll post on there, okay? So I hope you were able to learn some of the secrets of answering questions. So maybe I'll do electrolysis and electrochemical cells, or if you like it, whatever one you choose. Do I have classes? Someone said, do I have classes for SS1 students? No, unfortunately, because you have a lot of things to learn. I just prepare students to pass, and I've taught a lot of students, and they've passed in flying colors. So I believe that if we continue to do this, students will definitely keep passing, and they will not fail. Okay, so I'll end the class now, and I wish you guys